In episode 45, Verify Documentation and Uncover Undocumented System Behavior, we focus on a subtle but powerful discipline, checking whether the story on paper matches what systems actually do. Security programs often produce polished policies, standards, and diagrams that describe how things should work, while the running environment quietly drifts in its own direction. Verifying documentation is not a clerical task. It is a technical investigation into alignment, integrity, and truth. When you learn to do it well, you become the person who can see both the official picture and the living system behind it. A practical starting point is to compare policies, standards, procedures, and runbooks against implemented controls with care and curiosity. Policies might declare that critical systems enforce strong authentication, while standards spell out exact parameters such as password length, multi-factor requirements, and session timeouts. Procedures and runbooks then describe how administrators configure those controls, respond to alerts, and handle exceptions. Your job in this kind of verification is to trace a line from statement to configuration, asking whether the actual settings, scripts, and workflows genuinely match the written expectations. This comparison turns abstract governance language into concrete checks that can be evidenced during an assessment. From there, you move into data flows, which are often documented once and then left to age quietly. A sound verification effort walks the flows end to end, confirming sources, syncs, transformations, and retention behaviors rather than taking diagrams at face value. If a document says that cardholder data is tokenized before leaving a particular zone, you validate where that tokenization truly occurs and which systems see raw values. If retention policies describe specific time limits, you check database records, file stores, and backups to see how long information actually survives. This work exposes obsolete assumptions, forgotten integrations, and hidden dependencies that rarely appear in high-level documents. Interfaces offer another rich vein for verification because they sit where different systems and teams meet. Documentation may describe a service application programming interface with certain parameters, error codes, and rate limits, but only live testing shows whether those behaviors are enforced. You can exercise endpoints using the documented inputs, then intentionally deviate from those patterns to see how the system responds. If an interface promises a specific error code for invalid authentication, yet returns something different, that discrepancy matters for both security tooling and client applications. By treating the documentation as a hypothesis and the interface as an experiment, you reveal where the written contract has drifted. Runtime telemetry provides a complementary perspective because it captures what systems actually report about their own behavior. Logs, traces, and metrics should reflect the events, error conditions, and performance thresholds described in monitoring and observability standards. Verification involves checking whether expected log fields are present, whether key security events are recorded at the right level of detail, and whether metrics truly align with documented service level objectives. You may find that some critical actions, such as administrative changes or failed access attempts, are only partially visible. Reconciling telemetry with documentation helps ensure that when something goes wrong, the organization has the evidence it believes it has. Configuration states, feature flags, and environment variables are another source of undocumented behavior that deserves attention. Many systems rely on these mechanisms to turn features on or off, control debugging output, or select between legacy and modern code paths. Documentation sometimes glosses over these details, treating the chosen configuration as fixed rather than dynamic. Verification involves inspecting the actual values in different environments and asking which of them have security significance, such as toggles that disable logging or relax input validation. When you catalog these influences, you often uncover quiet switches that can turn protective measures into mere suggestions. Shadow endpoints, legacy paths, and debug toggles are frequent culprits in serious incidents, precisely because they sit on the edge of what is documented. A legacy management interface might remain reachable on a non-standard port, or a debug route might still respond in a staging environment that has been repurposed for production use. Verification here means scanning, browsing, and exploring beyond the official list of supported paths, guided by both historical knowledge and technical tools. When you find something that still responds but no longer appears in any document, you have identified undocumented behavior that needs a decision. Leaving these paths in place without explicit acknowledgement is a quiet form of risk acceptance. Failover, rollback, and maintenance procedures are another area where the written word and reality can diverge widely. Runbooks may describe orderly sequences for shifting traffic, restoring previous versions, or entering maintenance modes, often with optimistic time estimates. Verification means scheduling controlled exercises that follow those steps and measuring how long they actually take, what breaks unexpectedly, and which manual interventions are required. In payment contexts, this might include confirming that failover preserves required logging and access control behaviors rather than bypassing them for convenience. When the results differ from the document, you gain a clear agenda for either improving the procedure or revising expectations. Credential handling is especially important to confirm, given how often compromise stories begin with a key or password behaving differently than assumed. Documents may describe rotation schedules, storage locations, and break glass steps for emergency access, all of which should leave detectable traces in systems and records. Verification involves checking whether rotation events happen when promised, whether credentials are stored in approved vaults rather than improvised files, and whether break glass accounts are monitored and controlled. You may also review audit logs and access request systems to see whether the documented process is actually followed. Any gaps here become high-priority findings because they strike at the core of access control. Software Bill of Materials, SBOM, records, version listings, and provenance claims also need to be tested against reality. An SBOM might state that certain libraries, frameworks, or operating system images are in use, but artifact repositories and deployment manifests tell the real story. Verification involves cross-checking versions, build identifiers, and source references to confirm that the components described in documents are truly the ones running in production and other critical environments. This is particularly important when tracing exposure to published vulnerabilities, where a mismatch between declared and actual components can hide or exaggerate risk. Ensuring provenance accuracy strengthens both vulnerability management and compliance narratives. As you uncover mismatches between documentation and reality, recording deltas systematically is essential. Each discrepancy should be framed in terms of what the document claims, what the system actually does, and why the difference matters from a risk and control perspective. Some gaps will lead to defect tickets for technical remediation, such as closing an undocumented endpoint or correcting a logging configuration. Others will lead to document updates, especially when the environment has legitimately evolved and the written material simply did not keep pace. Assigning accountable owners for both technical and documentation changes ensures that findings do not disappear into email threads. To prevent the same divergences from reappearing, organizations benefit from establishing recurring drift detection. Instead of treating verification as a one-time project, you design a cadence and a set of lightweight checks that look for specific signs of change. This might include scheduled reviews of configuration baselines, periodic sampling of data flows, or automated comparisons between deployment manifests and SBOM inventories. The goal is not to eliminate all drift, which is unrealistic in dynamic environments, but to detect it early and respond deliberately. Over time, this recurring discipline keeps documentation and systems close enough that they remain useful to operators, auditors, and incident responders. A brief mental review of this episode's themes shows how they fit together into a coherent verification practice. You start by checking formal descriptions against implemented controls. Then follow data flows, interfaces, and telemetry to see how information truly moves and how systems respond. You examine configuration levers and go hunting for shadow behaviors that documentation has forgotten, while also validating operational procedures, credential practices, and component provenance. Finally, you record the gaps, assign work, and build mechanisms to catch future drift before it surprises anyone. Seen in this way, documentation verification becomes an ongoing lens for finding both hidden risk and opportunities for improvement. The practical conclusion for episode 45 is that this work becomes real only when you pick a specific document set and walk it against a live system. That might be a set of network segmentation standards, an application interface specification, or an access management runbook tied to a cardholder data environment. Scheduling a hands-on verification session with the right mix of engineering, operations, and security participants turns abstractions into shared observations. As discrepancies surface, they not only feed remediation and documentation updates, but also deepen everyone's understanding of how the system truly behaves. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.